Sorry, we back? Okay. So, how can we prove they're all different? If these are infinities, how can we actually prove that they're anything? Well, first off, we're not talking about the type of infinity where infinity plus x is still infinity. No, if it's infinity plus x, it's not infinity, it's infinity plus x. It's algebra. Or it's polynomials. So here we have, so as you can see here, the first two equations, can you see that? Are going to be aleph null minus, or aleph 1 minus 1, and aleph 1 minus 3. How can we prove these are different? The aleph 1s are always consistent, so we can just cut them out of the equation. But important note, if we just cut them out of the equation, what happens if we just cut them out? Well, we end up with -1 and -3. But that breaks it. We're looking for even numbers. Why is that? It's because the alephs are odd numbers. It's blurry. Don't know why. Sorry. So it's because the aleph 1s are odd numbers. So if you get rid of the fact that they're odd, that means we are now, if you cut them out, because they negate each other, we're only looking to make sure they're different. If you cut those out, but then also realize there was an odd number, now you end up with -1, and I'll write CP for change parity, and -3, CP for change parity. And because it was something minus, you can actually cut out the 1. So it just equals 1 and 3 CP, which means just change the parity. So we can change the parity to whatever, but we have to put it up 1 or down 1. So this is either going to equal 0 and 2, or it's going to equal 2 and 4. And that will continue for everything. This one here is aleph 1 minus 2 minus 3. So first off, we can just combine those to aleph 1 minus 5. And then to prove that's different, you cut out that and change the parity, and you cut out the minus. Because that's just, we were subtracting it. So assuming we did subtract it, because if we're cutting it out, we would have still subtracted it. Does that make sense? Because we're cutting it out, but we're also saying we did subtract it, and then as long as we're proving it different, it's fine. I don't know exactly how to properly explain it, but you can cut out the negative part. Even if you don't, it still just equals it starts equaling negative even numbers, which is still fine. So now you end up with 5 change parity. So again, then it equals either 4 if you're going down, or 6 otherwise. And I believe it would actually go up, because it is an odd number. So it should go up. It shouldn't actually go down. So that's only if you're, but it is infinite, so you have to change the parity. It should always go up. I'm not like an expert on this, but it should always go up. So you will just end up with the same 2, 4, 6. So aleph 1 minus 1 should still in this case equal 2. Or no, it doesn't equal 2. There's just a difference of 2. It doesn't necessarily equal 2. There's just a difference of 2. So bumping between them, there's a difference of 2. So does this make sense? I'm going to try and switch how I'm holding it so you can actually see it right up. Does that make sense? So so you get rid of the alephs, because they're the same and we're only looking for a difference. We assume we already subtracted, so you get rid of that, and then you have to change the parity, because they were odd, and subtracting odd from odd gives you even. So you have to change the parity, you go 1 up, and you end up with 2, 4, 6. And because we subtracted the alephs, it's not actually a guaranteed 2, 4, 6. We just know that there's a difference of 2. So every time it's going to be a difference of 2. So is an infinite snake on the tree possible? Yes, an infinite snake on the tree is possible, and it will be different by 2 every time, which is the same as what we saw before. 8, 6, 4, 2. In this case, it's actually descending, and it should still actually be descending. This should be the highest number, because this is this number minus 1. So this is still going to be the highest number here. All we're looking for is a difference of 2. It is not equal to 2. This is equal to the highest number. It'll be 1 below the infinite number. But all we care about is that there's a difference of 2, and it will be a difference of 2 going down each time. And so yes, the infinite snake is possible. And that's I don't know what this number is. I don't know what this number is. They're infinite, and the snake could be however long, but there will always be a difference 2 regardless. So yes, the infinite snake is possible. Leave in your comments any confusion. Maybe I'll do a follow up because I mean I don't think I explained it the best, but if you have any questions, if you're confused, let me know in the comments. If you have any other like questions about this stuff, or any other like math puzzles you want me to dive into, I like math. So if you want me to if you want to like ask me a puzzle or something, feel free. So hope you guys enjoyed. Remember, if you like my content, feel free to like and subscribe. I know this was different, but it was interesting and I wanted to do something, but I wanted to like do it. So hope you enjoy and I'll see you next time. Bye guys. So quickly before the end of this video, I actually realized something, which is that the way I actually solved the is this different is actually incredibly overly complicated. And there was just an easier thing you can do, which I have written down right here. It's just if you know polynomials, it's just polynomials. So aleph 1 minus 1, and then you'll minus aleph 1 minus 3. And so you just take off the polynomial. So you take off the parentheses, minus 1, and it's minus aleph 1 plus 3, because that's what happens when you take off the parentheses. Move around, so it's aleph 1 minus aleph 1 minus 1 plus 3. This equals 0 minus 1 plus 3. And then it's just 0 minus 1 plus 3 equals 2. So it's still a difference of 2, just easier because you can... I don't know how I was explaining it before. I was like, cut out this and cut out that. It can easily be done with the polynomials. So just wanted to put that in because it's a much easier way to figure it out.